Welcome to Study Loop.
Okay, for part A, we're trying to figure out the direction of, or the polarity, the pole, what pole is this as the top face, and so we use the right-hand rule. We know that the force, the y jumps towards the observer, so force is directed into the page in this z direction, and then current is moving to the right, so current is in the y-axis, in the y direction, and then magnetic field, therefore, by right-hand rule, uh, is in the um, top, or well, I guess this would be the positive x-axis, y-axis, and I in the positive x direction. So magnetic field is pointing up, and so current is, and so field lines are going from north to south. So top face is therefore south pole. Okay, and in part B, we know that the maximum force is current times length times magnetic field strength, times sine 90, which is 1. So current is maximum force over length times magnetic field strength. So this is 0.085 newtons over 0.1 meters as the length times 0.22 Tesla as the magnetic field strength, giving us 3.86 angstroms for current. And finally, in part C, what's happened is that so you have magnetic field lines going up in this way, and then you have the wire that was initially at 90 degrees to the field, rotated down by 10 degrees. So this is the new length. So this is the new length L prime. Initially you had L. So L prime will be L over cosine 10, as you can see from this figure. So what happens is that force, new force, let's call it F prime, is current I, that's the same, times L prime times B, and L prime is I over cosine 10 times B, which is the same, times sine 100. This is not sine 90 anymore, so that's because initially you had a 90-degree angle between the current and the field. Now you have a 100-degree angle because of this 10-degree rotation. So it will come out to be the same value. So ILB, because sine 100 over cosine 10 is 1. So this is ILB times 1. So this is exactly the same as F max that we had before, which is 8.5 times 10 to the negative 2 newtons.